I didn't know it. Okay, so okay, we're going to go ahead and get started. Hello and welcome to NOAA's National Ocean Service Science Seminar Series. My name is Tracy Gill and I'm the coordinator for this series. We have partnered with the U.S. Global Change Research Program, or USGCRP, on this fourth National Climate Assessment Seminar Series, and my co-host is Katie Reeves, the Engagement and Communications Lead for the USGCRP National Coordination Office. I will provide some seminar logistics and then Katie will introduce the seminar and the speaker. If you are interested in getting a PDF copy or a recording of today's presentation, Katie will list the relevant websites in the chat box, or you can contact me, tracy.gill@noaa.gov, or Katie Reeves, and our emails are in the chat box. If you are not on NOAA's weekly science seminar list but you'd like to be, please email me at tracy.gill@noaa.gov and I will add you to the list. Folks in the room, please sign in, silence your phones, and now Katie Reeves will introduce our seminar and speaker. Katie?
Great. Thank you, Tracy. Thank you to NOAA for hosting the 9th now of 11 installments of our webinar series focused on the findings of the 4th National Climate Assessment. I'm Katie Reeves, the Engagement and Communications Lead for the U.S. Global Change Research Program, or USGCRP. Before I say more about this presentation, I'd like to take a moment to remember Dr. Tony Genados, who passed away early last week.
Katie,
Tony was Yes, we're here. Tony was a highly respected global change scientist and a longtime participant in USGCRP. He, in addition to the tremendous work he did in his daily life, including at EPA, the World Resources Institute, and in his role as director of Boston University's Frederick S. Pardee Center for the Study of Longer Range Future, Tony was involved with 3 national climate assessments, most recently as an author on the Complex Systems chapter of NCA4 Volume 2, and he was also co-chair of the National Academy's Committee to Advise USGCRP. We send our deepest condolences to Tony's friends and family. The Global Change Research Act of 1990 mandates that USGCRP assist the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of global change. One way that we do that is through the development of a quadrennial national climate assessment. The 4th assessment was released in 2 volumes. The first, the Climate Science Special Report, was released in November of 2017 and covered in an earlier webinar series, which can be found on our website, and I will share that link shortly with you. The second volume, Impacts, Risks, and Adaptation in the United States, is the focus of this series. As the title indicates, NCA4 Volume 2 assesses the observed and projected impacts of climate change across the U.S., covering 17 national level topics in 10 regions. The assessment was released in November of 2018, and you can read and download it at nca2018.globalchange.gov. Today, I'm really pleased to welcome Dr. Victoria Keener as she presents on tourism and recreation in a changing climate, findings from the 4th National Climate Assessment. Dr. Keener is a research fellow at the East-West Center in Honolulu, Hawaii, and the lead principal investigator of the Pacific Regional Integrated Sciences and Assessments Program, or the Pacific RISA, as many of you may know it. Dr. Keener also does research on enabling practical applications of climate science for regional decision-making, with much of her modeling work using multivariate time series analysis and varied spectral methods to identify dominant climate trends and hydrological variables and how they change through time. Woo. In addition to research, as the lead principal investigator of Pacific RISA, Dr. Keener coordinates an interdisciplinary team of social and physical scientists that aims to reduce the vulnerability of Pacific Island communities to climate change by translating academic research into actionable knowledge for a variety of stakeholders at the local, state, and regional level. She was the lead editor and chapter author for the 2012 Pacific Islands Regional Climate Assessment, or PERCA, report, and she was chapter lead for the Hawaii and U.S. affiliated Pacific Islands chapter of the 4th National Climate Assessment, Volume 2. Dr. Keener received her PhD in Agriculture and Biological Engineering from the University of Florida. Thank you, Dr. Keener, for joining us so early today in this NOAA Science Seminar, and I'll turn it over to you.
Thank you. Can everyone hear me? Tracy, can you hear me?
I can hear you, Victoria. We're good.
Oh, okay.
Yes,
Yes, I can hear. All right, we're back. Great. Thank you for the introduction, and thank you for the invitation today to speak about this this topic that I am not an expert in. So I'll be speaking today about the subject of climate impacts on tourism and recreation throughout the National Climate Assessment Volume 2. So when I was asked to give this talk, I thought, yeah, sure, I'll summarize what I can, and then I realized very quickly that there was not actually a chapter or a sector called tourism and recreation, so it meant that I had to review the entire document and pull all of the relevant information from all of the 29 or so chapters. So there is a lot of text-heavy information in this presentation just because I pulled a lot of it out. Some of the photos I have on here, just to start us out, some of the varied ways that climate impacts tourism and recreation you can see in these. So for example, the eutrophication event in Lake Erie in 2018, the fire in Glacier National Park last year, Blue Ridge Parkway, and the timing of the autumn leaves and the tourists that show up to that event, which one of my colleagues who's from Vermont told me yesterday that the tourists that go to those are charmingly called leaf peepers, which I didn't know. Also, the snowpack loss in the west and in the northeast, seen there in Vail, and the coral reef bleaching events in Maui in 2015, and that continue to extend. So there are a lot of varied impacts. So one of the key messages is that a changing climate is affecting and will continue to affect recreation and tourism. And I was really shocked at pulling out all the information about how much it will and how expensive and how many lives it impacts and livelihoods. So another key message is that economies of some regions and different sectors are more dependent on tourism and recreation than others, but really all regions and sectors are impacted. Some of these areas are going to have losses of revenues and maybe an identity, but there also will be new opportunities as climate shifts and new regimes emerge. One of the frameworks that I thought was really nice to think about this was put in Chapter 22, the North Great Plains. They identified climate change affecting recreation through three main pathways. So first is the direct impact to the ecosystem, through a wildlife or fish population of interest. Second is change in a environmental condition that directly affects recreationists or tourists or tourism operators. And finally, a speculative effect, which is the effect of adaptation policies on habitat quality or recreational enjoyment. And so while that isn't documented yet throughout the either that region or in the chapters, they think that's going to come out later. The impacts are highly independent and compounding, so it's all related and they all build on each other. And then these proactive management strategies can help reduce disruptions to tourist economies and recreation. So at the end of this talk, I'll go through some adaptations that people are doing. A couple notes, everything in terms of dollars that I've noted in this talk is in 2015 US dollars, unless I specifically specify it in the notes. If there's a key statement from a chapter, then I've notated the chapter or the region at the end of the statement. So, for example, Chapter 22 NGP is North Great Plains, and those statements will be notated through the talk. And the figures, if a figure is from the NCA4, it has the figure number directly on it and some of the caption. And if not, I did put in some other figures. It just has the attribution either in the notes or on the figure itself. So in terms of climate variables that affect recreation and tourism, I just wanted to pull out some things that are impactful. Those include heat waves, extreme precipitation, frequency and intensity of storms and hurricanes, drought, reduced snowpack and sea ice, wildfire activity, sea level rise, ocean warming, and acidification. And if you want more about the actual change in these climate variables that affect recreation and tourism, I won't be talking as much about those today. And you can go to the NCA4 Volume 1 which is the Climate Science Special Report. And I have one figure pulled out about extreme precipitation change in there. And maybe Katie can put up the Climate Change Volume 1, or in Volume 2, Chapter 2 is kind of a summary of that. So in terms of the impacts that those climate variables affect, I've sectioned out into kind of an overview of where we'll be going in this talk. So biodiversity and ecosystems, such as the changes in seasonality, abundance of plant and animal species, the habitat loss associated or migratory species shifts, invasive species and pest outbreaks, coral reefs, so ocean warming and bleaching, how that affects diving or ecotourism, coastal and marine systems, so sea level rise, flooding impacts on airports, ports, and infrastructure and access, and fisheries and aquaculture. Next, national and state parks, so recreational losses due to decreasing snowpack or heat or wildfire or beaches, impacts on recreational waters, so fish and shellfish, algal blooms, wildfire and air quality, and livelihoods of Indigenous people. And I'll end again with a bit of adaptation information. So first, for biodiversity and ecosystems, most of these are direct impacts to the ecosystems and wildlife or fish populations of interest, as was identified in that framework, which impact recreational activities or tourist activities such as hunting, bird watching, fishing, or simply walking around outside. So landscapes are essential to regional identities and tourism industries. So for example, the moose population in the Northeast, or duck migration, or songbirds. And climate change influences the plant and animal species physiology, growth, mortality, distribution, and reproduction. For example, the autumn foliage tourism in the Northeast contributes billions of dollars to the regional economy. And species such as moose drive a multi-million-dollar tourism industry, and they're already experiencing increased parasite infections and death from ticks, identified in the Northeast chapter. They're also seeing in the Northeast warmer spring temperatures, bringing earlier arrivals of migratory songbirds, affecting when different populations of tourists show up. And some birds are not expected to migrate as far south in response to the winters becoming warmer, which affects both hunting and birding opportunities. I also wanted to give a kind of case study dealing with ecosystems to really show how all of these impacts are intertwined and compound upon each other. And this is an example from the North Great Plains chapter again. So that figure at the top from NCA4 shows changes in average stream flow. On the left, you see average stream flow, and then the change in average stream flow on the right by the mid-21st century. The darker blues indicate increases in stream flow projected, and the warm colors, yellows and reds, indicate decreases. So what they're seeing in the North Great Plains is shifts in habitat suitability in favor of warm water fish as opposed to the cold water fish and fishing that usually they support. And so they're looking at changes in the economy associated with the cold water fishing of $25 million a year under the lower scenario, RCP 4.5, and up to $66 million a year by 2100 using the higher scenario, RCP 8.5. So basically how this went was, in terms of what they saw in the climate change, they saw changes in snowpack, spring snowmelt, and runoff, resulting in more rapid melting and earlier peak runoff. This caused lower stream flows, especially in late summer. Combined with warmer air temperatures, the stream temperatures rose. One of the impacts was that they saw accelerated hybridization and genetic dilution of native trout species. What happened after that was the native cold water fish became more vulnerable to disease, and there was an outbreak of proliferative kidney disease in the native mountain whitefish in Montana, and this was in 2016. That giant fish kill ended in a month-long closure of 180 miles of the Yellowstone River to water-based recreation. And just from that month-long closure, they estimated the impact to local communities ranged from a little over $300,000 to $500,000. And I pulled an article with a quote from the governor of Montana, Steve Bullock, where he called the fish kill, quote, a threat to Montana's entire outdoor economy and the tens of thousands of jobs it sustains, noting that outdoor recreation supports more than 64,000 Montana jobs and brings in almost $6 billion annually. So events like this really do have a huge impact on local populations, the tourism and the economies of some entire states. Next, I wanted to address coral reefs. So within the U.S. climate assessment, reefs are discussed in the Hawaii and U.S. affiliated Pacific Islands chapter, the Caribbean, and in the Southeast chapter. This is a figure from the Caribbean chapter, which really shows the nice connections between climate-related impacts and the different types of responses, and ultimately how those affect ecosystem services in the human community. So you have those changes in ocean acidification affecting reef growth, making it harder for them to build their skeletons. You have elevating sea temperatures causing bleaching events, and then you have storm events causing structural damage to the reefs. So all of that is interdependent and affects ultimately shoreline protection, livelihoods, nutrition, lives, property, businesses, including recreational and tourist opportunities. We do see in the report a pretty consistent message that reef ecosystem services are projected to decline in the near future and extending into the farther future at the end of the century. What happens when there's a loss of coral reef structure? You see a decline in fish abundance and corresponding biodiversity, which negatively impacts tourism, fisheries, and coastal protection. So I just pulled out some summary statements about the impacts that reefs have. And this statistic from the oceans chapter is that under RCP 8.5, by 2100, they're projecting a loss of recreational benefits equal to about $140 billion. If you break those up by region, you're looking at potential losses of up to 90% of the reef recreation value in Puerto Rico by 2100. Some areas in Puerto Rico also generated about $217 million a year for tourism recreation activities and $1 million a year in coastal protection. In Hawaii, under that higher RCP 8.5 scenario, they're identifying an economic loss of $1.3 billion a year by 2050 and $1.9 billion a year by 2090. Also, soberingly, if we meet the warming reductions targeted by the 2015 Paris Agreement, those are only projected to delay the onset of annual bleaching by an average of 11 years. So this is more than being able to fix it. This is just kind of delaying some inevitable impacts that are already baked into the system. So how is that going to affect, aside from the loss of some of these ecosystems, how will that affect recreation and tourism in these regions? Well, so this figure shows the years when severe coral bleaching is projected to occur in the Hawaii and U.S. affiliated islands region under that higher scenario. So these darker colors around all the islands indicate earlier projected onset of annual bleaching events. So under the projected warming of about 0.5 degrees Fahrenheit per decade, all nearshore reefs in the region are supposed to experience annual bleaching before 2050. And some of those are sooner, happening in the late 2030s and some in the 2040s. But before 2050, everything is projected to be bleaching annually. So there are a lot of tourist and recreational opportunities that are going to be affected by these losses, and there are a lot of adaptations that need to happen. And I'll talk about one of the adaptations later. But now we're going to go to coastal and marine systems and talk about some of the impacts there. So coastal and marine systems are very diverse. They're composed of beaches, intertidal zones, reefs, seagrasses, salt marshes, estuaries, and deltas, and those all support fisheries and recreation and coastal storm protection in different ways. So coastal and marine systems are affected not only in terms of property and infrastructure, but also cultural landscapes that are impacted, historic structures that are present in these areas, and recreational structures that support some of that. So like a parking lot at a beach that might be flooded, or visitor centers at parks. So some of those impacts that we're seeing are, for example, in the Northeast, they've seen seasonal ocean temperature changes shifting their phytoplankton blooms, which is changing the timing of fish and invertebrate reproductions. And also in the marine region, changing the fisheries and spawning, both the presence of fish when they show up and where they show up. So some places are finding new populations and some less. And also I know that in the Pacific region, they're actually seeing smaller fish sizes on average as well. In the upper Texas coast, over 74% of beaches have been affected by sea level rise, with erosion averaging about 10 feet a year, which is pretty amazing. In Puerto Rico, they saw 60% of their beach transects experiencing erosion from 1970 to 2010, with 5% suffering very high erosion, with a beach loss of about 4 feet to 6.5 feet a year. So we're seeing a lot of beach loss in some of these places that are known for their beaches. So this map is from the Hawaii and Pacific Islands chapter, and it highlights potential economic losses in the exposure area of 3.2 feet of sea level rise in the island of Oahu. So the areas that are highlighted are potential economic loss per hectare, and these are in 2015 dollars. These are only losses from land and residential and commercial infrastructure. So there are a lot of impacts that aren't encapsulated in this, but you can also see that there are some highly impacted areas. The tourist engine of the state, Waikiki, is very highly impacted. You can see all those reds. Those range, that top bracket of damage, financial damage, ranges from $50 to $150 million. And again, that's probably low because we're not including anything except the damage to land and buildings. But you can see in that blow up, really, in the upper right corner, some of those high impact areas in Waikiki to the tourism industry. Next, I wanted to pull out one more case study relating to the coastal impacts, and this is about flooding in Charleston, South Carolina, and this is highlighted in a case study in the Southeast chapter. So historically, coastal cities were built just above what's the current mean high water, or the average height of the higher of the two daily high tides at a given location. So with the drainage systems that were built in these cities, they're gravity driven and they're designed to send rainwater into tidal estuaries. However, sea level rise in the last 100 years has meant that the stormwater systems in these areas are not performing as designed, which results in a lot of flooding. Charleston is experiencing more and more flooding. In 2015, they experienced 38 high tide flood events, and in 2016, that was up to 50 days a year of high tide flood events. And those are also called sunny day flooding. So it's not associated with rain, it's associated with high tide. And by 2045, those are projected to increase up to 880 events a year, which is frankly quite staggering. Each event in the past has cost approximately $12.4 million. And over the past 50 years with all that flooding, the gross damage and lost wages is estimated to have cost over $1.5 billion for the city. So obviously this is a big issue, and they've developed a sea level rise strategy that plans for 50 years out based on a moderate sea level rise scenarios. And as of a couple years ago, in 2016, they've already spent or set aside about $235 million to improve their drainage projects. So they have a quite comprehensive plan that they're working through in Charleston to address some of these some of these issues. And of course, Charleston is a big tourist location in the Southeast United States. Next, on the subject of recreational waters. So again, some of these sectors and titles that I've given to this do bleed into each other because there is a lot of overlap between different things. So while I can't represent all of the information that is in the NCA4, I've tried to pull out some highlights for you and encourage you to go look at these types of impacts and others if you're more interested in finding out particulars or in a particular region. So in terms of recreational waters, both the quality and quantity of water available for recreational use is being affected by climate change, which increase those risks and costs. As identified in Chapter 14, under RCP 8.5, they're looking at increasing temperature, water temperature, and low dissolved oxygen, extending toxic algal blooms by about 1 month into the future. So as I already mentioned, the algal bloom in August 2014 in Lake Erie introduced cyanobacteria into drinking and recreational water sources, which restricted use of the lake, both recreational and consumptive use. The warming of bay waters on the Texas coast has been documented for at least 35 years, which resulted, in conjunction with a drought in 2011, resulted in record high salinities in Texas estuaries, leading to a massive red tide algal bloom. There was a fish mortality event. Beaches were closed. About 4.4 million fish were estimated to have died. The commercial oyster season was closed, which was an economic loss for the industry, and the total event was a loss of about $7.5 million. It also impacts commercial and recreational fishing and aquaculture in these recreational waters. So for example, fresh and ocean fisheries are going to be increasingly impacted by warming, seasonal shifts, invasives, and drought. In the Pacific, the landings from the pelagic longline fisheries, just in Hawaii alone, is worth over $100 million annually. And they're projecting a 50% decline in the maximum catch potential under that higher emission scenarios by 2100 for the exclusive economic zones of islands in the central and western Pacific. So not only are we seeing a projected maximum catch decline, but also how these populations of fish will be moving around is fairly unpredictable, and there'll be some places that are some EEZs that are winners in terms of having more fish, and some that are going to have much less, which is a big issue for a lot of Pacific Island countries that make a lot of money either through selling their fishing rights or ecotourism for diving and fishing. Going on to outdoor recreation and snowpack. So one of the things that really came out throughout the report was the decline in snowpack and the cross-cutting impacts that that's having. One of those impacts, of course, will be on the winter recreation industry, which is quite significant in many regions in the U.S. There are projected declines in snowpack in the western United States and projected more rain than snow in the future in the central and eastern U.S. So I pulled out a couple impacts of reducing snowpack throughout different regions. In the Northeast, the winter recreation industry supports a lot of rural areas in particular. There are about 44,500 jobs that are generated and about $2.6 or $7 billion a year that is associated with that recreation. Under the lower warming scenario, they are projecting declines in visits and ski delays in the season by mid-century. And under the higher scenario, 8.5, natural snow and ice cover will only be economically viable in the far northern areas of the region by the end of the century. In the Northwest, for example, the low elevation ski areas already have struggled to stay open recently during winter seasons, and especially during the 2014-2015 season, which is talked about in Chapter 24. In the Northwest, outdoor recreation in general generates about $51 billion in consumer spending a year and about 450,000 jobs. When they looked at low snowfall years from 1999 to 2009 versus high snowfall years, low snowfall years had 2,100 fewer employees and $189 million less in ski resort revenues compared to high snowfall years. So they're really projecting that they're going to see more of that decrease in the future unless they start adapting. In the northern Great Plains, where cross-country skiing and snowmobiling are popular winter recreation industries, they're seeing projecting a decline under the low scenario by 20 to 60% by 2090, and under 8.5 from 60 to 100% by 2090. This figure is a map of showing the earlier snowmelt-related streamflow timing in the northeastern United States from rivers in 1960 to 2014. So this is historical data. And each symbol on that map represents the change for a river over that entire time series. And so these changes in the timing of snowmelt, we've already talked about how they can interfere with a lot of the ecology of aquatic species, and can also impact water management because of the different timing of winter and spring flows. And so really what they've identified here is that the increase over this time period of only 1.67 degrees Fahrenheit is thought to be that cause of average earlier streamflow timing by about a week, 7.7 days. So this is already shifting a lot of both ecological and recreational opportunities. This is a similar map showing the duration of sea ice cover, the seasonal sea ice cover in the Great Lakes region. And this is a time series between 1970 and 2013. On the left, it's showing the trend, the change in days per year, and on the right, it's the degrees Fahrenheit per year change. So it's showing that change in ice cover duration. And one of the interesting things that they were seeing the greatest rate of decrease in seasonal ice cover duration near the shorelines. However, the greatest rates of increase in summer surface water temperature occurred in deeper water, with smaller increases occurring near the shorelines. So those types of patterns have a big impact on winter recreation that concerns ice cover, ice fishing, things like that. So this next section, I wanted to talk about the impacts on national and state parks. So some of these we've already mentioned, but I wanted to pull out a few nice examples from the NCA4 of how the parks are specifically documenting these types of change. So our national parks are where we can really see a lot of climate changes on protected ecosystems that already have less human impact by design. So we can really see the changes that increased temperatures, wildfire, sea level rise, flooding, storms, invasive and invasive species have on these ecosystems. So for example, Superstorm Sandy damaged New York harbor parks, including Gateway National Recreation Area and the Statue of Liberty National Monument. But you can also see ecosystem shifts. So in Yosemite, they've seen the forest shift into subalpine meadows over that time period specified, and small mammals actually shifting 1,600 feet upslope from 1914 to 2006. And they identified climate change as outweighing other factors which might cause that. Also, there's a potential habitat shift of Joshua trees outside of much of Joshua Tree National Park, where they are protected, into areas where they are not protected in the future. And within Hawaii Volcanoes National Park, 18 of the 29 studied native plant species were projected to lose range into the future. concerningly, most high priority areas that are managed to protect plant biodiversity are projected to lose a majority of the native species within those sections. So a lot of the design of our park system protects some of these fragile ecosystems will be affected, and a lot of our money that we've been spending to conserve these regions will be shifting in terms of where the money is appropriate to invest in terms of conservation. Sorry for anybody who's snake phobic. I should have put a trigger warning in there, but this is from Everglades National Park. And this is an example of an invasive species. So a Burmese python is an apex predator that is sensitive to cold temperatures and is expected to be favored by the increasingly warm winters. So these unintentionally introduced python populations have expanded throughout the park and are reducing native mammal populations. And you can see why, because they're rather large. Going further into the subject of wildfire and air quality, projected increases in wildfire frequency are projected to reduce the ability of forests to support recreation as well as economic and subsistence activities. Oh, I see a question from Genevieve in the box. How will the new rule changes to the Endangered Species Act be likely to affect vulnerable species like Joshua tree and Hawaiian native species? Well, this is not my area of expertise. However, when we saw the government shutdown earlier this year, I believe it was, and I believe that what Joshua Tree National Park already saw impacts from that government shutdown. When they weren't protecting when there weren't park rangers in there, people were going in and chopping down trees and four-wheeling through the park and destroying sensitive habitat and trees. So I would expect that the changes would not be good and would negatively affect vulnerable species. Back to wildfire and air quality. So we've seen a lot of this. You can't have watched the news in the past couple of years and not seen the impact of wildfire across the western United States. And of course, this is going to affect tourism and recreation as well, both short-term losses as visitors avoid areas and maybe longer-term losses as people decide that they don't want to go into these smoky areas or risk being in a wildfire. We also see that the more frequent wildfire smoke increases health risks, which consequently decreases the outdoor activity time that people are willing to take going out there to recreate. And finally, we see that increase of wildfire near inhabited areas, leading to a wide array of different kinds of costs. So the forest and urban interface becoming closer, firefighting, health and safety impacts, property damage, insurance losses, higher fire insurance costs. We saw a fire insurance company in California go bankrupt this year. In Alaska, wildfire suppression costs of $25 million more per year under the lower emissions scenario are projected by the end of the century. Here's another sobering picture. This is from October of 2017 of more than a dozen fires burning through Northern California, which you can see identified in that left map. Dozens of people were killed. Thousands of more were left homeless as their houses were destroyed. Communities, even if they were distant from the fire, were affected by poor air quality. Even in San Francisco and the Bay Area, people were having a lot of asthmatic reactions and suffering from bad air quality. There was the most destructive fire in California's history, the Tubbs Fire, which caused an estimated $1.2 billion in damages. It burned parts of Napa, which is obviously a very popular tourist destination, and destroyed over 5,000 structures. I also wanted to talk about the impacts on Indigenous people, which are identified throughout the report and also in the tribal chapter in NCA4. So there are a bunch of different ways that climate impacts are expected to increasingly disrupt Indigenous people's livelihoods and economies. Those are not just subsistence living, but also Indigenous tourism and modern livelihoods as well. And a lot of Indigenous peoples their communities already face institutional barriers to self-determined management of water, land, and other natural resources and infrastructure that will be increasingly impacted. And this makes it harder for them to adapt to many of these impacts that they're going to be experiencing more and more as they do not have that the self-determined management that they need to be able to endure them. In terms of subsistence, in the Midwest chapter, they identified that portions of tribal lands in Michigan, Wisconsin, and Minnesota are important for hunting, fishing, and gathering native plants, all of which play vital roles in maintaining cultural heritage. In terms of impacts on Indigenous tourism enterprise, in Alaska, Native Alaskans use skins, fur, and walrus tusks for local subsistence economy and for clothing and crafts for local tourism. And the retreat of sea ice is really changing that habitat, which is important for fueling those industries. It also impacts the modern livelihoods of Indigenous people. As we've already talked about, ocean acidification, drought, and pollution and development are negatively affecting fisheries and ecosystems, which are drivers of tourism, which directly impacts the livelihood security of many Pacific communities. So in Pacific Island countries, industrial tuna fisheries account for half of all exports, about 25,000 jobs, and 11% of the total economic production. And so the changes in tuna fishery abundance will impact the livelihoods of Indigenous peoples. Additionally, in Hawaii, between 2011 and 2015, about 37,000 Native Hawaiians worked in tourism-intensive industries annually, which is about 12.5% of the Native Hawaiian population that resides in Hawaii. So a huge chunk of the Native Hawaiian population actually works in tourist industries, which will be directly impacted by shifts in climate. Finally, also cultural sites that are important to many different communities will be impacted. For example, 550 Hawaiian cultural sites were identified as being threatened under 3.2 feet of sea level rise by the end of the century. This map is showing how many Indigenous people are taking steps to adapt to climate change. So this shows all of the regions encompassed in NCA4 and shows the different types of resilience actions that different Indigenous populations are taking. So they're identified as the map as either planning, actual adaptation measures, monitoring and research, governance, youth movements, and I believe that they identified that the Pacific Northwest had the highest concentration of resilience actions in terms of being taken by Indigenous people. And I believe Katie will put the map URL in the comments. Thanks for that question. So finally, I wanted to end with the need for adaptation and what some industries and regions are already doing. So this figure shows estimated percent change in hours worked at the end of the century in 2090 under the higher emissions scenario. So projections indicate an average of 570 million labor hours lost per year in the Southeast by 2090. I know we're not talking specifically about labor hours here, but we are talking about time that can be spent outside, and this is relevant to that. So this kind of map shows the change in hours being able to possibly be outside in these different tourist industries or recreating into the future. So these were high-risk high-risk industries that are defined as agriculture, forestry and fishing, hunting, mining and construction, manufacturing, transportation, and utilities. So on the continental U.S., you can see here that need for adaptation across the region. One of the ways that coral reefs systems are building resilience is by reducing the potential impacts of climate on the coral population through coral farming or propagation, which is supposed to improve both the reef community and the ecosystem function for the fish that use that ecosystem. So this is a figure from the Caribbean chapter that demonstrates the different types of structures that they use for growing coral fragments, and then those corals that are selected and survive and propagate are replanted out into the reefs. Now, a lot of times the ones that they pick are from colonies that have survived stressful events such as bleaching events. Or, for example, here in Hawaii, a couple years ago, there was a maple syrup spill in the harbor, or a molasses spill. And it killed a great deal of the reef in the Honolulu harbor, which is already a highly impacted area. But not all of the reefs died. So there were some corals that made it through that crazy event, and they were harvested and are being grown in labs on the other side of the island to be outplanted. Of course, these aren't the pretty corals. These aren't the purple and blue and pretty ones. These are the brown, plain, ugly corals that they're picking and propagating. But any way to keep that ecosystem alive and help it make it through. This is another example of some integrated adaptation events that are going on in the Southwest. I thought it was a really nice presentation of different types of things that are going on in the Southwest region. I won't read all of this, but you can look at this figure. There's a lot more text in the actual figure, but they identify adaptations such as coastal protection, crop water savings, cultural fire restoration, desert soil restoration, health protection. That was a good one. To reduce heat-associated injury and deaths on trails, the city of Phoenix, with tourism organizations, developed a campaign that reminded hikers to bring water. They had ads and signs on the trail reminding them to stay hydrated and that it was hotter and to be aware of changes in environmental conditions. Branching in habitat, rooftop solar, water conservation, and wildfire fuel reduction. So these are all types of adaptation that are leading to more resilient tourism and recreational systems. Question from Nathan Walker asking if that means they're breeding corals for resistance to molasses. Well, that would be one way of looking at it, and also of any sort of kind of traumatic anthropogenic event where the waters are severely impaired. So really, they're picking anything they can find with coral resilience. If there is a population of coral that has made it through any type of tough event, they are pulling those and trying to breed those genes so they can put them in the system other places and outplant them. But yes, resistance to molasses is one of the things they've looked at. So another of the adaptations is, some tourist industries in some regions are not going to be able to strictly adapt what they're doing currently. They're going to have to shift what their recreational norm is. So, for example, in the Northwest and the Northeast, winter recreation is investing in artificial snowmaking. They're opening higher elevation trails and shifting north. There's only so far north you can go, however. In the Northwest, they're diversifying their businesses by creating more summer recreation opportunities so that they're not as dependent on the winter ski area revenue, but have more summer ways to make money. In Alaska, they're doing community monitoring for paralytic shellfish poisoning toxins at non-commercial places where people commonly go fishing and gathering for shellfish. In Bee Branch Creek in Iowa, they've designed a greenway space to control flooding and add parkland. So we're seeing things like that come more and more, where you're not only adding a flood control structure, you're also adding green space and recreational space as you adapt to changing conditions. Finally, they're not, even though there are all of these great examples of regions and sectors adapting to these changes, there are some things that are more difficult or impossible to adapt. So for example, the regional and cultural identity associated with a specific natural resource or pastime. So, the love in the Northeast of tapping maple trees for maple syrup, or watching the changes in autumn foliage. It's going to be more difficult to lose some of those regional pride and identities that are associated with these tourism and recreational opportunities, as well as, for example, places in the coral reef-centered areas where ecotourism may be centered around fundamentally altered ecosystems in the future, and we're not able to keep those economies going because the ecosystem is fundamentally changed. And so on that sobering note, I will end with a thank you for listening. And here is the website where you can check out all of the chapters and all of the information. And thank you for the invitation to present and the U.S. Global Change Research Program.
Great, thanks, Victoria. What a lot of great information. Folks online, folks in the room, are there any questions?
Hi, Dr. Keener. Just have a question. You started to elaborate a little bit on it, but how are some of these recreational hotspots sort of spreading awareness of these climate change effects? You mentioned that, like in Southwest, they were doing more to kind of raise awareness on sickness and health effects from the heat. But I think if the tourism industry can really make that connection of like what you do locally affects globally, and there might be some more progress in sort of mitigating some of these impacts.
Yeah, thank you for that comment. That's a great comment. That it is a huge opportunity that I see, and of course I don't know exactly what unless it's covered in what I shared today. I don't really know what other tourism and recreational industries are doing to really promote the education of climate change, both at a local and at a global level. I know that there are tourism industries that are taking this into account. For example, in Waikiki, the hotels that are on the beachfront stay very aware of changes in the beach, the dynamic beach movement, as well as sea level rise impacts, and are very aware of what is projected in the future. But in terms of the education, I think that's a big opportunity that maybe they're not capitalizing on right now that we could potentially help with. I also see a question from Joel in the comments that the impact on fishing was addressed, but he's curious if there was an assessment of how other warm recreation activities such as boating, hiking, golf, etc. may be affected. So we did talk about hiking a little. I did see hiking impacts mentioned throughout the report, mostly from wildfire, but also from things like temperature rise. Just as hikers aren't going to want to hike in as the heat goes up as much. But I didn't see as much on things like boating and golf, unless it's something like an entire river was closed to recreational activities, and because of either a fish kill event or eutrophication, and it resulted in a loss of revenue. But I haven't seen anything comprehensive on that. Someone else from GCRP is welcome to jump in if you have any more information for Joel.
It looks like we have a few more people typing in comments or questions, so we'll wait a minute.
Victoria, this is Jennifer, and I was thinking about my reaction to your report. Like, viscerally, I felt like, holy cow, last chance to see, and that kind of experience of panic when I listened to your presentation. And I don't think that that's a very sustainable reaction to your presentation. So I'm just curious, how do you deal with that when you are going out with this kind of information to audiences to make it feel less panicked and maybe like maybe more of a sustained fall, as it were, or harnessing opportunities rather than only focusing on, oh crap, there's nothing going to be left, I better get there soon.
Yeah, the whole global warming tourism, disaster tourism type of industry. Well, that's a much bigger question that I'm qualified to answer. But I think probably I know that I and a lot of other scientists and researchers that I work with are dealing with exactly that feeling of kind of eco despair, climate change despair, and the feeling that it's all happening so quickly and we have to go see it now, and is there hope? And I'm sure a lot of people who are on this call are dealing with the same feelings, and if I had a great response to that, I would love to share it. But in terms of this is a talk that was meant to summarize the findings in the National Climate Assessment, so I focused on that. But when I give talks of this kind of thing to public audiences or guest lectures or students, I do try and end with things that personally I find hope in. Some of those are the adaptation measures, but a bigger thing is that the youth climate movement that we're seeing right now, focusing on hopeful political action and change that I believe is necessary in order to combat a lot of this. Sorry, that's not a better answer.
It's a hard question. Thank you.
And then we have do you see the question from Justin Zulner? We are working on a coalition here in the Pacific Northwest, sports teams, zoos, aquariums, convention centers, airports, music venues, etc., to leverage their collective influence to engage the masses here in our region to combat climate change. Assuming our influence leads to collective actions that can be taken, in your research, did you find a few actions that we could ask people to take in the Pacific Northwest that would have the greatest impact to slow our current trajectory?
Oh, that's great that there's a coalition being formed. That's great news. And while I don't have specific recommendations for the Pacific Northwest, I would recommend that you contact the lead authors of the Pacific Northwest chapter to get some detailed insight into what kinds of trends might be the most impacted by collective action in the region, and even what kind of policies might come out of that. Great comment, and I look forward to hearing about how that's going. I hope there's something going on like that in the Hawaii and Pacific Islands region as well. I also see
a link to that chapter for you.
Thanks. I see from Dave Reed Miller, are you aware of any cross-island planning or sharings of lessons across Hawaii and the Pacific or between Pacific and Caribbean in terms of dealing with climate impacts on tourism and the coastal communities whose economies rely on it? Are there lessons from recent extreme events, e.g. Hurricane Maria, that are transferable? There's definitely been sharing of lessons from Hurricane Maria in Puerto Rico for the planning community, disaster planning community in Hawaii. So I actually gave a talk a couple months ago to the Emergency Management Sub-Planning Committee, I believe it was called, for the city and state of Honolulu. It was the fire chief, the police chief, the Coast Guard chief, the lifeguard, the EMS. They were all in a room, and they wanted to hear about how the interdependencies and the issues that were exposed in the aftermath of Hurricane Maria might be dealt with in a similar event on Oahu, where Honolulu is. So we pulled out a lot of the interdependencies that came out of a report submitted by RAND about the recovery in Puerto Rico, and really compared it. And a lot of that was very relevant. So for example, here in Hawaii, we talk about the impact to the port. And if the port closes down, what's going to happen? How would we open the port back to get all of our supplies? We only have 3 to 7 days of food and medication on the island at any one time. So if we're cut off, things can get bad really quickly. However, in Puerto Rico, they reopened the port in 24 hours. What the problem was there was only one road, one main road around the perimeter of the island, and it was pretty much impassable. There were also no truck drivers to get the supplies from the port to the different places around the island. They couldn't get through the road, and there was no refrigeration once they got there. So at every chain in that, at every different link in that chain, there was something that wasn't necessarily foreseen that caused some issues. And the emergency planning group that I presented to here was very interested in hearing about that. There's also a question from Maggie. Thanks is actually going to ask about last chance tourism, where people are flocking to the Great Barrier Reef in the Arctic to see it before it disappears. Yep, unfortunately, I am one of those people, and I went to the Great Barrier Reef a couple of years ago. But you know, there is that urge to see these ecosystems and these features that we love before they're forever changed in a new environment.
All right. Well, thank you, Victoria. We're at the top of the hour. Thanks for a terrific presentation. And Katie's going to let you know about next week.
Yes, thank you. Thank you from us at USGCRP, Dr. Keener. This was fantastic. We learned a lot, and for getting up so nice and early for us. I encourage all of the listeners to check out Dr. Keener's chapter. It's chapter 27, I believe, of the assessment. I've dropped that link into the chat box. And I hope that you will join us next week for the 10th seminar in our series. That is going to focus on international effects and complex systems in a changing climate. And that will be with Dr. Meredith Muth from NOAA and Dr. Leon Clark, now of the University of Maryland. So thank you so much for being here today.
Thanks for joining us, everybody. We'll see you next week. Have a great weekend. Thanks again, Victoria.
Thanks. Bye.
Bye-bye.